Hi, everyone. This is Sebastian Traeger, Managing Director of the Reliability Center, and welcome back to another episode of Reliability 4.0. As always, we're on a mission to help make the world a more reliable place. And today we are joined by Rafael Padilha with Ingredion. Rafael, we are thrilled to have you. Thank you so much for joining us.
Thank you very much for inviting me to this podcast. It's an honor to be here. Look forward to talking to you this
Great.
morning.
Well, thanks so much. Well, I would love to hear, and I know our audience would, a little bit more about Ingredion and what you all do as a business.
Yes, Ingredion is a business to business company. We provide solutions to all types of industry. Uh, we we manufacturing modified starch, sweeteners, plant-based protein, and Ingredion is more than 100 years old company, American company. We have about 40 plants across the globe, 18 plants, 19 plants in US, Canada. This is a little bit of
It's great.
Ingredion.
Yeah, that's amazing. You serve there. Tell us about your role there and how long you've been there.
I'm the reliability director for US, Canada. I've been working for Ingredion for 7 years. I had the opportunity to work in three countries, Brazil, Colombia, and now in the US. And I'm responsible for the maintenance and reliability strategy for the 19 plants in the US, Canada.
Okay, wow, that's a big job. Well, I always like to ask folks kind of their origin story a little bit. You were from Brazil, so when you were a child in Brazil, did you dream of being a reliability manager, or how did that kind of process play out?
No, not at all. As a child, I just dreamed about playing soccer and just playing. So by the time I was growing, I wanted to be a doctor, medical doctor, maybe, or engineering. And due to the facility I had with math and physics, I decided to go to the engineering university. So my background, I'm electronics, electrical, bachelor engineer. And then after that, when I graduated, I started working the ABI group with automation, instrumentation, and electrical maintenance. And is when my career started inside reliability.
Great. Okay. And then from there, you said you've worked in a number of different countries along the way.
Yeah, so in the ABI group, the culture in this company is always challenging you to change positions. So I had the opportunity to start in automation, instrumentation, then I moved to utilities. So it's an operation area. I had the opportunity to learn about operations. Then I moved to reliability and capital projects and start managing maintenance, engineering, and utilities at the same time. After that, I moved to Unilever for 3 years as associate director. I had world-class manufacturing under me, which is a continuous improvement methodology that got apart from TPM in
Okay.
some moment. This methodology is interesting. Professor Yamashita is the responsible for this methodology, and that allowed me to have a broad view of how an operation should work with excellence, and that helped me a
Good.
lot in my history inside reliability.
Good. Well, I want to drill down on what you're doing in your company, but before we go there, I always like to just ask, what do you like to do outside of work?
Yeah, so I have two kids, so enjoy time with them. I think what we enjoy a lot is barbecues and drink a wine with my wife and grill some steaks, and I think this is very embedded in the Brazilian culture, and I keep it here too. So
It's great. Well, I love what is it called again? Churrasco? What's the
churrasco,
Yeah.
churrasco.
I've actually had the privilege of going to Brazil a couple of times, including, Sao Paulo, where we did
Wow.
that. I got a chance to trek in the Amazon for about a week, which was just incredible. So yeah, I love the country and the culture. So that's fun that you guys have continued on with that. Talk to me about your current role, and specifically, I like to start with kind of the goals that you guys are solving for. What are the goals, the KPIs that you solve for across all the plants?
As maintenance reliability, I'm responsible for part of asset performance. Of course, there's another part that which the responsibility relies on operations, another part from engineering. So I'm responsible for the implementation of a management system that we develop in Ingredion. That's Ingredion Performance System. We have a reliability pillar, and my responsibility is lead the implementation of this pillar for this region and ensure standardization of process of maintenance reliability management process, and of course tracking OEE, so increase asset availability. As main drive, we have breakdowns, break-ins, unplanned shutdown. That's the breakdown impact in your EE. So understanding the loss that's caused by maintenance in our OEE. Those are the main KPIs we use to track. Of course, maintenance costs, mechanical stores are two important KPIs that we also want to track to have the right cost for our plants, not the minimum cost. The optimized and right cost is what we pursue.
It's great. And I'm curious, like as you implement those strategies and those KPIs, I'm sure technology is a part of that. What
Yes.
technology do you find essential to the work that you're doing?
So first is your asset manager is your Bible. Everything you have to do has, has to talk to your asset manager. So every technology, every process, you need to be reliable. You need reliable information, and
Hmm.
and and that's the part several reliability professional they don't understand it, and they start trying to detect the failures and not ensuring the right work order cycle. If you want to be reliable, you have to have good information inside your asset manager. You need to identify easily your bad actors, to focus your efforts in your management process to be robust and to be able to deliver reliability. So now we have, of course, this management process ensuring the standardization of the work order cycle, the blueprints of work order. We have digital technologies supporting the reliability team to have a early detection of failures. And the main thing we aim here is we need to have the information in the asset manager to enable a reliable planning scheduling to increase execution performance.
Great. So for you, it's like, hey, we need a backbone of the right data. Without that, what's the point of even starting to solve problems if we don't capture that data and feed it back into a work order system?
Yes, and there's one point that I always work with my team is almost all maintenance reliability professional underestimate one simple tool, which is the asset criticality, right?
Hmm.
So it was interesting in one conference speaker asked, "Oh, who has asset criticality in place?" And almost nobody raised their hand. And asset criticality is the first tool to help you deliver criticality. So sometimes you are in a plant that you have 20,000 pieces of equipment. Where to start? You cannot start with your gut feelings or because someone told you to start this way. So the asset criticality should help you to identify, especially your single points of failure, which are the most important piece of equipment you have in a plant. And that there is where you have to start. You must start your single points of failure and start having your detection, start having your FMEAs, start having your maintenance plans, start having your execution at a top level in your single points of failures. You start having 0 days of backlog in your single points of failure. That way you stabilize your plant, and then you expand to the remaining assets according to your asset criticality.
Basically, you're like, hey, we don't need to think about all 20,000. We need to think about the 10 or 100 that have the highest, criticality points,
Yes.
single point of failure. If we get those right, that'll at least keep things going, and then we can sort of figure out the others.
And there's another point of view that I said, for depending on the single point of failure, I don't want you to be efficient. What I mean by that, I want a redundancy and I want a spare parts in my mechanical stores, right? So I lived in one of our plants, 125 horse power pump was not interlocked, and it was a lubrication water pump for the seals of 24 other pumps. And there is a down day, and during the startup, the operator forgot to turn it on, start the plant, and damage 24 pumps. So 2 days more down because of a single point of failure that stop all my process, and say, hey, for this point, I want a redundancy, I want an automation, and I
Huh.
want the spare parts in my mechanical stores. Because
Yeah.
if one pump breaks down, you have the spare parts to fix it, and you have the redundancy to prevent this from happening again.
It's
and
good.
and this comes from the asset criticality. You can take those decisions through your asset criticality, and with this evaluation you can start requesting capex for reliability. So that's what I call capex for reliability. I try to reduce the criticality of some single points of failure.
It's good. I like that. I can see how that's, yeah, not, if you don't start there with that viewpoint, I can see how you end up in kind of the weeds a little bit and all that. Let me ask you this. Now, our company, obviously, we specialize in root cause analysis. So I like to ask all of our guests, where does root cause analysis fit into the reliability process? How important it is to you, and how are you doing it?
It's super important. As I told you, great part of my background is TPM and world class manufacturing. They enforce a lot the use of RCA. And inside the IPS, the ingredient performance system, we create one block of the pillar is the RCA pillar, the problem solving. And this block started in the reliability pillar in the beginning of the journey. And now this block sits under the management pillar, and the management pillar is applicable for all the areas of operations.
Huh.
And the maintenance team is truly responsible to find the triggers based on some loss. So based on quality issues, safety issues, OE losses, even cost losses, and discuss with the POT, align with the plant manager, and then start doing this tracking of the problems that happen that trigger the RCA. Or RCA or RCA first is very focused on the 5G. I don't know if you're familiar from the 5G from TPM, but basically we translated from the Japanese. I don't know how to pronounce it, the Gamba, Genbutsu, but it's go get, gather, give, and gauge. So
Okay.
basically, you go to the field, you do examination, you get the evidence, you talk to the operators, you go to the systems and you look at the history, the data. You go to the SAP and look at the history data. You look at their engineering data sheets, information. So you give the theory and then you gauge the standards. So we focus a lot in the 5G because in this program, we more and more we try to push down the 5G for the operators and technicians.
It's
When you
great.
have in the late shift a breakdown, the first to see is the operator, then the technician. So those guys, they have the very good and momentaneous information to gauge the RCA correctly. So
Great.
we used to say, and we experienced that about 85%, 80% of the RCAs could be identified. So use a well done 5Gs.
Huh. That's great. It sounds like you're very dedicated to, like, yeah, we
Yeah.
want to do RCAs as part of our reliability process for sure.
Oh, yes. When you have a low maturity program, usually the reliability engineers they are doing RCA sometimes in things that are not the most important thing of the plant. They are doing because they like it, or so the management system connects the final indicators, the final results to the triggers. So this channel is oversold. I won't allow any breakdown greater than 1 hour without an RCA. So every time I have a breakdown here is bigger than 1 hour, I have to have an RCA. And this person is responsible. So the maintenance manager or the maintenance lead or even the reliability engineer or the ops manager, they will get together and do the RCA with their team.
It's good. It's good. It's good to hear that process. Shifting a little bit into innovation that you're seeing. To what extent are you all utilizing AI in your work? Has that started yet, or are you? Yeah,
Yeah,
where do
we
you?
first time I start discussing AI was 2019 with a startup AI sensors, and start to understand the model of machine learning, and we were able to start the implementation in several plants. Now we have about 14 plants with AI sensors, online vibration sensors, vibration temperature with AI in the background. They're able to learn from the process, understand our batching scenario, and more give more accurate insights of failures like misalignment, lack of lubrication, cavitation. That's something very important for the maintenance reliability team. Show to ops, hey, I'm having a lot of failures due to cavitation. Why you're cavitating this pump? Process engineer, come here. Ops team, come here. What do we need to do to not cavitate anymore? Is there any automation to improve? It's operational training. So yes, we have about, I believe right now, 15 plants in Americas. When I look US, Canada, Mexico, and South America, we have about this inside more than 1,000 piece of equipment covered by
Wow.
those AI sensors.
And it seems like the that'll only grow from where you are today as you put these sensors in and are able to kind of track what's happening.
Yes, yes, and of course, when the plant understood that it was easy to install, accurate insights, and of course that will make everybody's lives easier. So it was my dream when I was a maintenance lead, a maintenance manager, have a sensor that point me, hey, you have a problem in the very beginning. No, it used to be the opposite. I used to be called because of the breakdowns, and nobody saw that was happening. And now it's different. You can manage those events and set up a down day or set up even a 4 hours downtime to fix the thing. Sometimes just a lubrication. You go there,
Hmm.
you adjust your lubrication program, and more it's gonna be towards this way. So now we have also sensors interconnected with the lubrication system. So the
Hmm.
sensor is there reading and adjust the lubrication automatically. And that's the future. That's what we envision. And more, uh, the reliability engineers will turn this role of reliability engineer and technical guys to more and more data scientists or data analysts.
Yeah.
So they will have to gather all those information, start modeling, because before the problem is getting the data, now is we will have a lot of data. So what's a good data, what's not a good data, and that's going to be key for success. Understand the partners and the solutions that will help you to understand what's a good data,
Hmm.
and you can leverage results.
It's good. Yeah, basically, yeah, we used to have the problem of like we don't even know what's going on. Now we have so much of it. We got to figure out kind of what almost to some extent like your criticality analysis on the data. What's the data
Yeah,
that matters and what's the data that doesn't matter?
imagine now not only the piece of equipment information, but looking at your process in general. So you change the viscosity here and the temperature here, and the system start modeling and say, hey, if you operate this for X time, you're going to generate a failure mode. That will be possible. That will be very possible. We have your cars, right? 10,000 miles, you have uh, to stop to maintenance. 5,000 miles, depend on the way you drive, depend on the
Right.
fuel you're using. That might change. So our industrial assets are going to the same pathway.
Hmm. Fascinating. It's good. Well, it's been great talking to you, Rafael. You definitely have a lot you've thought through related to this. As we kind of close, I would love to hear. I always like to ask folks, what's kind of one thing you would impart on your sort of younger self? If you're kind of everything you've learned now, if you could have, tell a younger reliability engineer something, what might it be that would help them?
Yeah, I think reliability is a management system.
Hmm.
It's not only is not only detect the failures that are possible to be detected. So you can have the best detection system, but if you don't have the management system with routines, with process map, with good KPIs, and embedded with operations, it will be hard to be reliable. So learn also about management system, doing RCAs, doing FMEAs, connecting the tier meetings in daily production with your planning scheduling process. That's gonna be key for success to be reliable.
It's good. That's great. That's a great final word. Well, today we have been just really thankful to have Rafael Padilla with us as a guest. Thank you for the insightful conversation. We really appreciate it. And to all those listeners out there, again, this Reliability 4.0 podcast is all about helping everyone learn and take steps to being more successful at bringing reliability and specifically through technology to whatever you're doing. If you're looking to solve problems specifically around RCA, we'd love you to check out our company, reliability.com. We've got plenty of training and resources and materials. If you're looking to dig deeper and put a solution in place, we have our in-house software called Easy RCA that allows you to not only do RCAs really easily, but also to analyze the data coming out of them so that as a organization, you can be smarter about which ones you're doing. And again, as always, this podcast is about helping to make the world a more reliable place. So thank you to our guest again, and we look forward to seeing you on the next episode of Reliability 4.0. Take care.
Bye bye. Thank you.